Our first question in reaction assignment number 4 asks us to calculate the present value of money. And so we're going to use the present value chart. And the present value of money is discussed on page 98 and 99 of your textbook, and it instructs us to use the present value chart on page 458 and 459. That's much easier than using the formula, so we are going to do that. So we're looking at number 1, and we're looking at the present value of money. So we're going to pull up that chart. Here's page 458, and we're looking at a $17,000 payment in 3 years. So what is the present value of that money if it is discounted at 3%? So when we flip to the present value of money chart on page 458 in the back of your book, and we look at we're looking at a period of 3 years. So here is our 3-year period. And then our first discount is 3%. So here is our 3%. So we match those up down here and find our multiplier of 0.9151. And all we do is we take that 17,000 and we just multiply it by that 0.9151, and we get 15,556.70. And what that figure means is that is the present value of $17,000 3 years from now at a 3% discount rate. So it also asks us to calculate that same situation, a $17,000 payment over in 3 years at a 5% discount rate and then at a 9% discount rate. So we're still looking at that 3-year period, and we're just going to use that same formula, but instead a 5% discount rate, we use this multiplier, 0.8638, and then for the 9% discount rate, we use this multiplier, the 0.7722. And that 5%, multiplying by that 5% discount rate, gives us a present value of 14,684.60. And this 9% discount rate gives us a present value of 13,127.40. So you can see that as this discount rate goes up, the present value of money, of future money, becomes less and less and less. All right, the next question asks us for the future value of $12,000 invested at 8% interest, compounded for 10 years, compounded every year for 10 years. And the future value of today's money is talked about on page 94 and 95 in your textbook, and it gives a formula, but again, it gives you an easy way out in which you can use the future value table on page 454, 455. So if you're following along, look at page 95 in your textbook. That is the calculating the future value of present money. And so we're going to look at that table. So let's jog on over to page 454. And our question was, we've got 8% interest. So let's do that, 8% interest. Let's make my pen red here. 8% interest. And our period was, it was over 10 years. So if we follow these two down, we see the multiplier of 2.1589. And all we're going to do is we take our $12,000. Would be nice, wouldn't it? $12,000, right? So 12,000 times 2.1589 89. And that gives us a future value of 25,906.80. And if you got that by using the formula, good for you. This way is easier. But you can really see the value of compound interest when you look at this problem. This money doubled. This money more than doubled over a period of 10 years at 8% interest. And 8% interest is pretty high. That's a pretty good return. If you've got money in some kind of a stock market fund or mutual fund or whatever, and it gets 8% over 10 years, that's pretty good. You double your money. So that's what number 2 looked like. Our third question is looking at the future value of an annuity. And the future value of an annuity is talked about on page 456, 457. And this question asks, you are putting in $4,500 into an IRA every year for 30 years, and it gets 6% interest. So at the end of your 30 years, what is that investment going to be? So this is an annuity because you're putting in $4,500 every year for 30 years. That's what an annuity means. An annuity either means you're putting money in every year for a certain amount of years, or you're taking money out every year for a certain number of years. And in this question, you're putting money in. It doesn't really matter. So we are looking at the future value because we're putting money in every year and looking at it in 30 years. So that's in the future. So we're going to pull up our future value of an annuity table, and I gave you that, page 456. And it's the same thing. It gave us our interest rate at 6%. There it is. And I realize this is a little bit hard to see because we have to scroll all the way down here to 30 years. So we come down and we come across and we see what that multiplier is at 6% for 30 years. And all we do is that multiplication. So we've got our 4,500. And that's pretty good. We're putting in 4,500 every year for 30 years. And we multiply that by this 79.0582. And that gives us, at the end, a whopping sum of $355,761.90. So that shows the value of saving early and saving consistently for your retirement. Look at that. After 30 years, $4,500 a year gets you $355,000, assuming a 6% interest rate, which is a little bit optimistic, but definitely doable. So what these 3 questions asked you to do was look at the situation and decide what it's asking you to calculate. This first question asked us to calculate the present value of a payment in the future. You're collecting the $17,000 in 3 years. What is it worth today? What's the present value of that money? And then in the second one, it is asking you to calculate, it's asking you to calculate the second question is asking you to calculate this future value of the $12,000 that you have today. So you've got $12,000. What is the future value of that? That's why we looked at the future value table. And then this third question, in this third question, you are looking at an annuity because you are contributing $4,500 every year for 30 years. And that's what the book talks about as the definition of an annuity. So part of what this assignment asked you to do was interpret what was going on in each situation and then apply the appropriate table to calculate either the present value, the future value, or the future value of an annuity.